All right, guys, we're on the back side of the Geometry Day 9 notes reviewing our circle. All right, so number 3 says that the endpoints of a diameter of a circle are P, which is at 6, 1. 1, 2, 3, 4, 5, 6, 1. Okay, and Q, which is at -4, -5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And this is the endpoints of the diameter. So we had one like this the other day. Okay. So our circle kind of looks like this. Okay, just to give you a visual. And I want you to write the equation of the circle in center radius form. And so remember, structure of the circle equation stays the same for all that. And then we just need to know what the center is. And we need to know what the radius is. Okay, neither one were given. However, we kind of talked about that the other day, that the midpoint of the diameter is the center of the circle, and it's probably somewhere around here. Okay. And so we talked about the midpoint formula. Okay. Midpoint, what do you do? Add them together and divide by 2. So hopefully that'll help you remember the midpoint formula. Okay. And remember that it's a point. All right. And so x's come first, and that's what we're doing first. We're adding our x's. One of our x's is 6. The other one is -4. And then we will add our y's. One is 1 and one is -5. All right. So the average of the x's, 6 plus -4 is 2, divided by 2 is 1. And the average of the y's, 1 plus -5 is -4. -4 divided by 2 is -2. And so if I find the point 1, -2, there it is. Okay. And that's going to be my center. So the center of our circle is at 1, -2, which means in our equation, we're going to need a -1 here with the x and a +2 here for the y. Because remember, think of the center, the opposite of the numbers, because in the equation are the negatives, right? And then our radius. Okay, so we're going to go ahead and create that right triangle with our radius. So we'll go, we'll use this as the hypotenuse of our right triangle. So all we have to do is go over and straight down, and there's that right angle. All right, so it looks like one side of our right triangle has a length of 3, and our other leg has a length of 1, 2, 3, 4, 5. And we're going to take those numbers and put them into the Pythagorean theorem. And so we end up with 3 squared plus 5 squared equals our hypotenuse squared. That's 9 plus 25, which is a grand total of 34. We take the square root, and we end up with c equals 34 is not a perfect square, so we're going to keep it underneath there. Okay, and so now we can see that our radius has a square root of 34. But remember, when you put it into the circle equation, we square it. Okay, and so the square and the square root will cancel each other out, leaving us with just a 34. And now we have center radius form. Okay, and then in part B, they want us to do general form. And so remember, again, in general form, we do 3 things, right? First thing is we're going to expand those parentheses, keep the plus sign, expand them again. We also have to be equal to 0, so we're going to subtract the 34 so that we're equal to 0. Okay? And we're going to go ahead and put these together. So x times x is x squared. This is outer is going to give you a -1x, another -1x for a grand total of -2x, and that's going to give you a +1. Keep the plus sign. Here we're going to get y squared. This is 2y, this is 2y, so grand total of 4y, and that's a +4. -34 equals 0, and now we're going to go ahead and order our terms, okay? So we have x squared plus y squared minus 2x plus 4y, and 1 plus 4 is 5, minus 34 is minus 29, equals 0, and there is our general form. All right, we'll practice one more time here. Number 4 says write an equation of the circle shown in the graph below in both center, radius, and general form. And so nice thing is we have our center, it looks like there, at -3, 4. So we can go ahead and start writing our equation. We'll have x plus 3 all squared plus y minus 4 all squared equals, does not look like we have a radius though. So what we're going to do is we're going to go ahead and connect. And I think I have two options. I have 2 points on my circle. It doesn't matter which one I connect it to. However, I think it'll be easier for me to figure out my sides of my right triangle if I connect it to 0, 0, a little bit easier. All right, so that's going to be my radius here. All right, but I'm also going to make that my hypotenuse of my right triangle. So I'm going to go straight down and over. Okay. And so if you think about it, if this is the point -3, 4, you're going to go over -3. Therefore, this is a 3. And then you're going to go up to 4. Therefore, this is 4. And so now we have our 3 sides of our right triangle. And 3 squared plus 4 squared has to equal our c squared, or our hypotenuse squared, or our radius squared, whatever you want to call it in the problem. Okay, 9 plus 16 is 25. And what's nice about this one is that 25 is a perfect square. And so our hypotenuse comes out to be 5, okay, which is really our radius. Okay, but remember that we have to square that, okay, to put that into the Pythagorean, or into our circle equation. And so this ends up being 25. Okay, and there is my center radius form. All right, now to get general form, we're going to go ahead and expand. And again, and bring over the 25 so that we're equal to 0. Okay, and we're going to go ahead and put together. So we're going to have x squared, that's 3x, that's 3x, so that's 6x, and that's 9. Okay, this is y squared, minus 4y is minus 8y, and that's going to be a positive 16 minus 25 equals 0. All right, time to order them. So we have x squared first, then y squared, then plus 6x, then minus 8y, and then we have a 9 plus 16 minus 25, which actually cancels each other out, right? 9 and 16 is 25, then the minus 25, so we don't have to write anything except our equals 0 at the end. Okay, and one last one. It's a short one. It says, write the equation of a circle with a center at 0, 0 and a radius of 10 in general form. Okay, so before, again, we do general form, we have to do center radius. And you notice that the center's at 0, 0, so this actually makes it really easy because there's no numbers grouped with the x or the y since their center's 0, 0, and equal to our radius squared, which would be 100. Okay, so this is actually center radius form. They want general form. So the cool thing is there's nothing to expand. The only thing we need to do is bring over the 100 so we're equal to 0. And so that was a little bit of a different case there scenario at the end. All right, so a little bit different, a little bit easier, but it makes you think twice that you're doing it right, but you are. Okay, all right, guys, so hopefully that was a good review of circles. And so then we'll jump into going from general form back to center radius form in our notes for Algebra 2. All right, guys, I'll see you then.